Today, I have this tool. This is a stone. Now, I assure you, using this stone, I am going to explain step by step Newton's second law, starting with stating it, and then show its mathematical calculation. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the force applied and takes place in the direction in which the force acts. Now, I am going to use this stone to show you how the momentum of a body can be changed, and then I am going to show you mathematical relationship between the applied force and the rate of change of momentum. Follow me step by step. Now, this stone, I'm going to vary the force acting to it so as to change its speed. So when I change the velocity of the body, as momentum is equal to mass times velocity, it means that even the momentum will be changing, and that change will be depending on the force applied. Let's go. Observe well these two motions of a stone. The first motion this way, as you see. Now look at the second motion. As you see, this way. Now, my dear Rama, in these two motions, you may deduce that during the first motion, a stone was moving slowly. It means that the force applied was smaller force, and it resulted to the production of the smaller velocity. As the momentum is equal to mass times the velocity, even the momentum of this stone produced in the first motion was small. But in the second motion, the velocity of this stone was increased. It means that even the momentum that was produced at the second motion was higher compared to the momentum in the first motion. Now you may conclude that the momentum of a body increases as the force acting to it increases, and it takes place in the direction in which the force acts. As the force was acting in this direction, even the stone was moving in that direction. After this demonstration, now let's see Newton's second law of motion mathematical. We have said that the force applied is direct proportion to the rate of change of momentum, meaning momentum mass times the velocity. So it is mass times change in velocity. Final velocity minus the initial velocity of a body over time is the rate of change in momentum. After that, we move the proportionality sign where we introduce constant into this expression, where we find force is equal to constant times mass change in velocity divided by time. But in this constant k is equal to 1. K is equal to 1. Now, if k is equal to 1, when you introduce 1 here, it remains the same this way. That force applied is equal to mass times the change in velocity divided by time. Now, we know change in velocity over time is equal to acceleration. So, we finalize by saying force is equal to mass times acceleration. This is according to Newton's second law of motion, that force is equal to mass times acceleration. So we'll be using this one, force is equal to mass times acceleration, in various calculations concerned with the Newton's second law of motion. Yes, this is what I've prepared for you today in this session, and make sure that you share our videos to various group members. You have various WhatsApp groups. Make sure that you share with your fellow students in various schools so as to get our lesson on time. Thank you. Have a nice moment.